Hey guys, in this video I'm going to be taking a closer look at the RCA WO-33A oscilloscope I picked up recently. Get this off eBay for a very reasonable buy it now price. And what especially got me interested in this is that it's in fantastic condition. Even came in the original tattered box with manual, with probe, and of course the scope itself. And the scope, aside from some dust, I don't know if it's really ever been used. It's just in fantastic condition, as is the probe, which is an oddball thing. Certainly not like modern scope probes that not only use a BNC connector, but typically don't have three connections at the end of it. We'll get into what those are all about later on. And it's not your typical vintage screw-on type connector. This is a smaller type. So there's plenty of vintage equipment that use the larger ones, like this VTVM. But this is a little itty-bitty version of it. Some sort of mini microphone connector or something, I imagine. I'll leave that off for now because I have not powered this up yet. I just unboxed it in a recent unboxing video, but I have not powered it up or looked inside. I figured it would, even though it looks to be in great condition, it would be sensible to pop the cover off, make sure all the tubes are in place, there isn't something horribly wrong inside. I think all I have to do is take a couple screws off either side. Now, you've seen me use scopes in plenty of my videos, especially this Hewlett-Packard 54600B digital scope, which works fine, although it's an early generation digital scope, and I really wouldn't recommend it to anyone. Go with a new production digital scope. The prices have gotten so reasonable on them. Or down here, I've got a crusty old Tektronix 465, very popular 100 megahertz analog scope. But the reason I got this is that it's from the era of the TVs that I work on, and it was designed specifically for working on TVs, and I thought it'd just be a neat thing to play around with. Okay, I think... What? No, it's not going anywhere. There must be more to it than that. These sides won't even budge. I don't think that's how you take it apart. I think I gotta take off a few more screws, and maybe the front, I think, just pulls out of this whole case. Probably aren't any disassembly instructions in here. Maintenance, lots of adjusting it. Great, take it to an RCA service center. Well, I can't really do that if there is anything wrong with it, so I'm just going to have to figure it out. There's 4 screws up here that probably just hold these on, which is for wrapping the power cord around, I think. No screws on the back. 2 screws in the front, but that's probably for holding that switch on, which just leaves 3 on the bottom, so that's what I'm going to go for next. Something feels a little bit looser now. knob off. This is really nothing to... Oh, okay, that's one way to do it. Just put it face down and lift the cabinet up. Alright. Take the rubber band off this power cord. Just break it off. And there she is. Alright. Baby oscilloscope. A little bit of a mu metal shield around the neck. More commonly they go up a little bit further. Provides magnetic shielding made out of a special kind of metal called mu metal. You know, the old crusty caps are still in here. We got cadmium oxide forming on the controls. Original filter caps. All RCA branded tubes. Power transformer. That certainly is as pristine as you're ever going to find a piece of vintage equipment. These caps are pretty reliable. I think they might be really early plastic film. Well, it might be paper. But generally they hold up fairly well. Electrolytics, well, that's a bit of a question mark, as is this big guy here. Certainly a paper cap, half a microfarad, 1000 volt. That's the filter cap for the high voltage. But I'm inclined, I see that everything looks nice, to give it a try. Give it a try on my Suncor PR57. I can monitor the current flow, or current draw, and it's fused and all that good stuff, and hopefully I can reform those electrolytics. Eventually I'll replace that paper cap and just kind of leave the rest in place. Eventually, if I really feel the need to use this to any extent, I could go through and completely recap it and check the resistors, calibrate it, and all that good stuff. Alright, let's give this a try. Turn it on here and use this for the power switch. Put this in the ammeter mode. Well, that's encouraging. Current draw didn't shoot up. Tubes are lighting up. It's running very little current. Tubes are conducting, going up. Oh yeah, it's a solid state, or rather tube rectifier, so of course the only current draw on power up would be the tube filaments. Hey, look at that. We've got ourselves a trace. Controls seem to work. Yep, all the controls are working. Intensity, focus, horizontal, vertical position. Cool. Well, let's sit for a little while. Monitor the temperature on these caps, and then fire up a function generator and see if we can get a squiggle on that screen. I pulled out my WaveTech 148A function generator and plugged in the vertical input cable and hooked it up to the blue lead. And here we go, WaveTech on. Hey, look at that. Cool. Decrease the output amplitude a little bit. And let's see if we can get this to trigger Now this is not a standard scope, so if you know anything about scopes or you've only used a standard scope, you might find this rather confusing. Typically you'd have a horizontal time base and a vertical attenuator, and this sort of does, but it's really, as I say, customized for TV work. So, oh, and you'd have triggering controls and a trigger level, and trigger source. Well, they call this sync, and you got external and internal right now. So it's external, which is probably why it's just going nutsy, because it's just syncing off of the line. So let's try internal, and it's still not so hot. Well, we do have this control, and hopefully by turning that, kinda, sorta, should go the other way. Not really wanting to sync too much. Try a different sweep rate. Yeah, that's more or less working. So I'll have to check the manual. I think I should be able to sync a little better than this. Oh, but that just reminded me. This is a complex function generator, and I've got it doing FM sweep right now. So let me turn that off. I think I was having a little trouble with that complex waveform. Let's see. There's a little bit better. Get down the horizontal gain. So it's not exactly a precision instrument in terms of when it's calibrated or not. Like, this is the horizontal gain, I can just vary this. I'm not sure if that's calibrated or this is calibrated. And there aren't even any horizontal. There's no squares on it like you typically see. But what this comes in handy with, that way you'd really use it when you're servicing TVs, is you get yourself a service manual, and if you look in these, pictures like this. So what you do is you just compare that to what they say it should be and get a rough idea of the voltages. You're not really intended to measure precise microsecond horizontal intervals with something like this. And not really any retrace blinking in it either. It's only got a few tubes in it, so they could only do so much. Sine, triangle, unstable, square. Not the greatest bandwidth, so we get some overshoot there, and there's no compensation. A more modern oscilloscope probe, like this guy, has the trimmer there, and you can use that to eliminate overshoot on this fast rising and falling edges there. Amplitude modulation. This thing has trouble syncing on anything but, it seems like, a periodic simple waveform. It's just a pretty simple AM modulated carrier here. It's not really being able to sync on it. There we go. Anyways, let's turn that off. So what is up with these two inputs? Well, one of them is a direct, basically just a direct wire right into the scope. The other one has a resistor in series with it to provide a higher impedance input and divide the input by 10, which is a times 10 probe, in other words, which is pretty standard these days. You can see in here. So the yellow, a 9 meg resistor, I should say. And that capacitor there, that's what a more standard scope probe, that's the one you could adjust. So right now I am going on a direct input. Let's try going over. Now we can see that the waveform is considerably smaller now. Crank the output amplitude to this, but it only goes up so high. So when you're poking around in TV circuits where you have a really high output signal level, you'd want to use this. Or for sensitive circuits where you need high input impedance and you don't want to disturb them. And of course I can also increase the range on this. And also notice this is wideband and narrowband. They call that a feature, that they decrease the bandwidth at the more sensitive ranges. Okay. Also, this might be a limitation of their amplifier design, but they call that a feature. And there's a built-in calibration mode. So this scale here, when it's calibrated, that reads directly in volts. So 1 volt, 2 volts. Over in cal, it's an internal reference waveform. I gotta look up the instructions, but you're supposed to, I believe, then adjust this. Maybe so it's exactly 1 volt, something like that, and then your device is calibrated. Then you can switch back to this and compare it to your input. And then read directly off the scale to see the input amplitude. Variable sweep. So I don't know what the calibrated position is. These are marked here on sweep of 15, 150, 1500, 15 kilocycles, 75 kilocycles. So rather than something like 1 millisecond per division or 1 microsecond per division, they give it in frequency. So I guess that's the repetition rate of refreshing the screen from one end to the other. Now this also supports a horizontal input, so you should be able to use this for doing alignments when you drive this from the output of a sweep generator. Or if it doesn't, you can use this phase control when you have a sweep generator that runs sweeps off of the AC line voltage. So what I propose to do is next time I'm working on a TV chassis, which won't be very much further in the future. I'm going to try using the scope to troubleshoot it if needed, or make any adjustments and maybe do an alignment with it. But for now, I think that's going to be it. You can get this manual off the BAMA, the Boat Anchor Manual Archive, if you want to take a look at it for yourself and read more in depth about how it works and how those functions work. Here's the entire schematic. As I said, there's not much to it. Or look on eBay. These pop up all the time. They are fairly inexpensive. And this is a great manual for explaining in detail what each control does and the typical things you do with it. For example, synchroglide lock, which a lot of my sets use. When you got a coil like this on the horizontal with an adjustment sticking out the back, you're supposed to adjust it so the waveform looks like that. Great use for a scope like this, because you really cannot adjust that properly without a scope. But you don't need a complex scope, you just need to make sure the waveform looks like that. Don't care about the absolute voltages or time or anything, just the way it looks. So I hope you enjoyed this look at an RCA WO-33A oscilloscope. Not sure the exact time frame, I'm guessing mid-50s. See if I can find a date in here. 662. That actually might be a little bit later than I realized. Might be early 60s.